Hello everyone, my name is Dennis with DonkeySec or Donkey Security, whatever your heart desires, and in today's video we'll be going over the TryHackMe Lab Azure DevSecOps. Let's explore this room, begin our journey into the world of Azure DevSecOps. Alright, let's go join the room. Nice, we're in the room here. So yeah, we learned the basics of DevSecOps. And basically what DevSecOps is kind of like software development, but it's just focused on a shift left mentality, which that means it's security focused, right? So security is always incorporated to the beginning of the software development lifecycle to the end of the software development lifecycle. So the end would be, testing it out in production state or such as like that. So now we know the basics and have gotten to grips with many of the tools and terms that come along with DevSecOps. Well, what now? As you aim to specialize in DevSecOps, the mission becomes preparing yourself for real life scenarios that these roles would find you in. DevSecOps pipelines. What are pipelines? Set of automated processes and tools that allow both developers and operation professionals to build and deploy code to a production environment. Excuse me. Becoming more and more prevalent in the cloud because of more and more valuable skill set. This room aims you to give you access to realistic Azure cloud environment where you'll be interact with DevOps services available with Azure, guiding you through how you may interact with these services as a DevSecOps engineer. Okay, we have our prerequisites right here, and yeah, let's go get ready onto it. Let's complete this now. Task 2, Azure DevSecOps. In the modern world, CI/CD. What is that? What is CI/CD? Continuous integration is a software development practice that involves automatically building, testing, and implementing changes to an application source code, and that is practiced by an increasing number of organizations. And with this comes a rising need to develop methods of securing the environment that is being built and deployed in, and have DevSecOps engineers carry this out. Of course, when you're hired by a company in one of these roles and asked to secure their continuous improvement slash, forgot to click CD as well, continuous deployment of software deployment term for deploying code to ready production environments automatically without any interaction from a human. For example, the automation of tests and then deployment of the code. Methods you use to secure it will differ depending on the type of installation. Is it on-premise or is it cloud-based? Of course, there are overlapping similarities that are common to implementing CI, continuous integration, CD, which is continuous deployment. Security in both kinds of installations. Still, some unique considerations might take into account due to the nature of each. On-premise CI/CD has been covered in the continuous integration and build security room. This room, we begin to focus how to secure an environment in the cloud. Before we do that, let's explain why you might choose to host your application in the cloud versus on-premise. So this looks like it's on the cloud, and this looks like it's on-premise. So an on-premise continuous integration slash continuous deployment solution offers the security benefit of having complete control over the hardware that runs it. It's all the configurations made to that hardware and the isolation of the environment from the internet using firewall rules. What is a firewall? A security tool, hardware, or software that is used to filter out network traffic by stopping unauthorized incoming and outgoing traffic. Rules. This complete control is desired or in many cases required by organizations requiring this level of control for compliance purposes. Then on-premise would be the way to go. However, a cloud-based solution offers many benefits, including but not limited to easy to set up, fast, reliable, scale or downscale based on demand. These benefits are enough on their own to make an argument for a cloud-based solution, especially for modern demand-driven applications with almost infinite scalability, unlocking all kinds of power for your application in the billing for what is used aspect of the cloud, providing in many cases a more cost-effective solution. Answer to the question, which one should I use? Of course, it depends on what is being hosted or deployed and will change on a case-by-case basis. Still, the vital thing to note for this room is just that because a cloud-based solution doesn't offer full control of hardware, it doesn't mean a cloud-based continuous integration slash continuous deployment solution can't be secure. You need to know class-specific security considerations and the right services slash tools to make use of. Welcome to Azure DevSecOps, all right? So we already talked about Azure DevSecOps. The responsibilities of this just depends on the cloud-based CI/CD installation is self-managed, which means the cloud-hosted infrastructure that you would install and manage the CI/CD software on, or fully managed, which you are provided with an out-of-box pre-installed CI/CD pipeline. For this room/module, we focus on a fully managed CI/CD suite and the greater cloud environment in which it is hosted. The chosen CSP, what is a CSP? Cloud Service Provider, which is a company which offers scalable cloud computing resources on demand. The cloud resources CSPs, cloud security providers, offer include power, data storage, and applications. Yeah, for this module is Azure. You'll be placed in the Really DevOps project, which you'll need to be secured over the coming rules using DevSecOps practices. The following tasks will brief you on DevSecOps missions and give you the keys to your next Azure home. Which solution would give you more control over your environment? On premises. Yep. Reason why it's on premises is because security benefit, having complete control over the hardware that runs it, all configurations made to the hardware, and the ISO for using if available. So yeah, basically that hardware is you controlling it, and all those configurations are made to that hardware. So yeah, gives you more control over the environment. Which solution is ideal for environments which scale up or down rapidly? Cloud, the cloud solution, right? Welcome to Azure. All right, welcome in guys. We do have our Azure lab here. Okay, ready for it's coming in. Think Factory. It's online merchant, sells PC parts. Okay, they sell a lot of stuff. Okay, no physical stores, so they use the cloud. Web applications being hosted in the cloud. Azure tenant. Even hired to help secure the deployment and deployment. Okay. However, before you can help Think Factory secure their Azure host web application, you'll need access to the Azure tenant. All right, so let's click this right here. Let's click Join Lab. And then we're gonna have to give the labs 2 minutes to set up, and then we need to navigate to this HTTP address. Click Open Lab here. Now we're on a different page. The DevOps project may default to your local languages, so probably set first switch to English. Am I in English already or no? Actually, let's click this user settings, time and local. Those are English. Okay, yeah, we're all good. We would have to click save here. Right, know my surroundings here, right? So as a DevSecOps engineer, you won't exactly be architecting the infrastructure or organizational structure. That will most likely be done by the architecture team. However, before we plunge you into an Azure environment, we're going to break down exactly why you're being placed so you have some context. Here's a very high level architecture diagram. Yeah, definitely very high level. Shows exactly where you'll be operating throughout the course of this room and module. DevOps organization, THM DevOps, was first created for this module. Inside this organization can be defined one or many projects. A project was spun up for you when you click Join Lab. Inside this project admin may have defined one or more many teams or many repos to store secure code. All right, DevOps organizations, DevOps right here, project team 1. Team 1, Repo 1, yeah, I assume what it says right here, working side is a project admin may have defined one or many teams to or many repos right there to store source code. All right, the first thing here should be introduced here, Azure DevOps. Azure DevOps set of cloud-hosted DevOps services that Azure collects into a single SaaS. Software as a service is a method of providing software to users. This software / application will run in the cloud, and users will pay to use it via subscription as a service rather than buying it. All right. Streamlines the processes of developing an application software in the cloud, making it easier to collaborate across teams on a project with all the services you need collected in one place. Silly fly. The Azure services that collectively made up Azure DevOps are Azure Boards. This service allows for agile work, planning and tracking down Scrum and Kanban methods, and also allows for dashboard visualization. Project managers would also use this to visualize and plan ongoing efforts. As a DevSecOps engineer, you're likely to only interact with the service when assigned work items to work on in your daily Scrum call. If that's the method being used. If curious, more can be found about the Azure boards here. Azure Repos. This service provides Git repositories and team foundation version control. So your code can be source controlled. This really will be access to source code, and DevSecOps engineer ensure that is secured. Azure Pipelines. Your application will be built and released in Azure Pipelines, which supports CI/CD and is language and platform agnostic. Azure Test Plans, a collection of tools that can be used to test your application. Azure Artifacts. This is integrated package management, allowing teams to share packages such as Maven, NPM, NuGet, Python, and more. In this architecture, diagram above, you can see that DevOps organization allows for its collection of projects, or in this case, a Think Factory. There is only the need for a single project. Within a project, you will find the services listed above. Routines can be created and assigned to different tasks, and repositories will be tied to. It is within the Think Factory's only project that you're being placed in, and that's where all the teams were able to develop, build, and release their web application. As part of the DevSecOps team, it's your job to secure these processes and therefore the application. With that covered, let's show you around. So it looks like we got our boards, repos, pipelines, test planes, and artifacts. Let's go back here. Maybe click this projects. Click on this. Yep, click on this right there, and that, yeah, we have our boards and artifacts. As discussed about the service, respectively as numbered in the screenshot, can be accessed by clicking. Okay, nice. Which Azure DevOps service would you like to access source code? I believe that is called the Azure Repos, right? You know, source controlled. It's where you access the source code. As a DevSecOps engineer, ensure that's secured. Team is looking to share a Python package with you and the rest of the team. Which Azure DevOps service would they use? They would use Azure Artifacts. This is basically the package management, and then you can also use Python in that package management. So the answer will be Azure Artifacts. And which Azure DevOps service would your application be built and released? Azure Pipelines, right? Reason why is because application will be built and released. Azure Pipelines support continuous integration and continuous deployment. That's for Azure Repos. Mentioned in the previous tags, Azure Repos is a set of version control tools that can be used to manage source code in software development projects. Azure Repos has the following features: support of different version control systems, including pipelines like Git and Team Foundation version control. Makes version control a seamless process for developers familiar with these systems. Given that Azure DevOps provides a collection of cloud-hosted services, it makes sense that Azure Repos can be integrated with these other services, making for an efficient deployment processes. As it is common with version control tools, Azure Repos allows for the branching of source code and subsequent merging. Azure Repos offers security features that can help protect source code, some of which will be covered in this task. Azure Repos have many features that facilitate team collaboration, such as code review features and feedback mechanisms. With these features, Azure Repos can support small teams as well as large organizations. The basics of Azure Repos covered. Let's take a tour of what we have available to use in the Azure Repos service. First, let's click on the Repos button within our project. So let's click on this Repos. Now click on the drop down menu, and then we have 1 through 7. We have files. So we can add some code here. Port repository commits. So it looks like it's AD, but it's a repository maybe. Commits or DevOps. So looks like it's a user. Pushes for some updates, branches, tags, pull requests. You can do pull requests. And advanced security. Secret scanning, dependency scanning, code scanning. So this is a full list of what you can do with each of those. I'll let you guys just pause the video right now. We can go through them. The importance of source code security has been covered in rooms like source code security. That's such a trippy sentence. This part of the test, we'll take a look at how this can be implemented in Azure Repos context. The first security practice we're going to take a look at is branch policies can be used to protect and secure important branches during the deployment process by allowing you to require a minimum of reviewers, requiring a minimum of approvers, requiring a minimum of successful builds before a branch can be merged. Then requires a link worked item used to track different kinds of work in Azure boards before a branch can be merged. And there's more on there. Having your code stored within an Azure repo versus a third-party repo such as GitHub has a key advantage of leveraging the cloud-native security model that Azure DevOps has. In other words, because the Azure Repo services operate within the Azure tenant, everything a DevSecOps engineer has to deal with on a day-to-day basis, such as security configurations, access controls, to manage directly within the organization's existing Azure infrastructure. This helps reduce the risk of external account compromises affecting your code/repos, which will be likely to happen using third-party services like GitHub. As well as implementing branch policies, there are other best practices you can follow to secure an Azure repo, including creating branch protection rules can work alongside branch policies to secure code in Azure repos. Instead of enforcing change management standards, Branch protection rules can help ensure that only certain authorized users can approve changes, as well as with all source code security. One of the most important things to watch out for as a DevSecOps engineer is any sensitive information that someone is attempting to commit, to avoid it being immersed into a repository's main branch and its history. Right, what Azure Repos security practice allows you to secure important branches by, for example, requiring minimum number of approvers, that is branch. Yep, basically these are all branch policies right here, right? What would you use to ensure only certain authorized users can approve changes? Creating branch protection rules, you can help ensure that only certain authorized users can approve changes. Branch protection rules. Nice. Right, Azure Pipelines, right? Cloud-based service, right? As mentioned. So entering Azure Pipeline's cloud-based services is mentioned in previous tasks, and it's part of the Azure DevOps suite. As you might expect, this does what it says on the tin. Service enables users to build, test, and deploy their applications, heavily supporting the CI/CD process. As per Azure, this Azure Pipeline service boasts many benefits for those working in a DevSecOps capable workspace. Azure Pipelines is a language and platform agnostic, support .NET, Java, JavaScript, Python, Terraform, and more. Pipelines can be deployed to different targets at the same time. The Azure Pipeline service, just like Azure Repos, integrates seamlessly with other services, including the Azure DevOps suite. We'll see instances of what this integration can look like towards the end of this task. Its integration capabilities also extend beyond the Azure DevOps suite and work with platforms like GitHub. The build process works on Linux, Windows, and Mac OS. Now that we covered what it is and how it can be used, let's take a quick tour of the service. Navigate to the Azure Pipeline service by clicking the Pipelines button on the left-hand side. Once you're in the service, you'll see the following. Right, so I do see pipelines here. We do have one pipeline, no runs yet. Then we have our environments, where we create a Kubernetes environment. Can we actually create one? No clusters found. Yeah, we gotta create a cluster first. A library. We have our library as well. And then obviously what we went through, just a little bit more explanation and detail. Just pause the video right here. Running a pipeline in Azure Pipelines. Now we got our bearings. Look at the process of running a pipeline with the Azure Pipeline service. First, let's take a look at the YAML code. What is YAML? It's a markup language data serialization language that is human readable and useful for managing data. Makes up the Think Factory pipeline. It's a pipeline which deploys their eStore web application. Oh yeah, definitely an interesting running a pipeline in Azure Pipelines right here. Look at that. Let's break it down because I'm kind of confused here. The file starts with a trigger, references the main branch. So here's the trigger, the main branch. Means the pipeline will trigger automatically whenever changes are pushed to the main branch. Next up, the pool is referenced. Pool Ubuntu latest. The pool run is defined. You see where this pipeline will run on a Linux-based machine using the latest Ubuntu image. Okay. Variable section stores reusable values that can be referenced to the pipeline. Here we are defining the variables we need to deploy our code to an Azure App Service. This will be expanded on shortly. Okay, so we have the code for Azure Development Services, Azure Subs, Pipeline, Test Pipeline. Okay, cool. Next part of the language mentions steps. These steps are the next part of the pipeline language mentions steps. These steps are the tasks and scripts that are needed to create, configure, and deploy our resources via an Azure App Service. Steps right here. Yep. These are all the steps needed to deploy the resources via the app service. Some scripts. As promised, as part of Think Factory deployment includes the Azure App Service. Let's briefly discuss what it is. After all, you can't secure something if you don't know what it is. That is true. HTTP-based service hosts webbing applications. Definitely can develop the application in whatever language they want. So the Azure App Service plan set of computer resources needed for the web to run. For this room, not required to know how to create an app service plan, but it can be helpful to know that inside these app service plans are defined OS region, number of virtual machine instances, size of the instances, and the pricing tier. It has some key features right here that deploys for the web application, which includes Dockerizing our application, host a custom Linux or Windows in-app service. You can also run a sidecar. What's a sidecar? It's a processor service which runs in parallel, supports a primary application of your choice, which from a security perspective, help in many contexts. For example, recording the DFIR, digital forensics incident response, obstacles that come with an thermal containerized environment. Azure App Service can guarantee high availability as an app service across the global Microsoft data center infrastructure and can be scaled up or either manually or automatically. Authentication can be done using the built-in authorization component with authorization, possibly using federated identity providers such as Microsoft Entra ID, Google Facebook, X, or Microsoft accounts. Azure App Service has many features beneficial from a security perspective, including compliance, ISO, SOC, PCI, creation of IP restrictions and managed service identities, and protection against subdomain takeovers. More on this is here. Now we discovered what is a pipeline. Let's go do it. Deploy the code. So yeah, let's do this really quick. Pipeline is my lab. Okay, I do see my lab right here. Click on that pipeline. Click Run Pipeline. Let's run the pipeline. Click the master branch. This is the master branch right here. I click Run. I'm gonna click Run right here. Okay. Message needs permission. Will appear. Click View on this message. Okay, there's the permission. Let's click View on this message. Now we see the options saying permit. Let's permit it. Granting access will permit these. Okay, for all waiting. Okay, yep, permit it. Permission is granted on the bottom of the screen. The deployment process will take a few minutes, but eventually the code will be deployed to an Azure App Service. You can click on the job to see each of the individual steps is complete. And okay, before it's done, okay, let's see. View 10 changes, I believe. Oh, there it is. The job's running. Job preparation commanders. Oh, the job said failed. The script failed with Xcode 3. Create app service if that exists. What did I do there? Supposed to create an app service? I don't remember, unless I'm missing something here. I don't think I was created an app service. No clue why. Let me know in the comment section if I'm missing something, but as of right now, I don't think I'm missing anything. I just went across the screen. Yeah, I don't think I'm missing anything. I could be wrong though, however. Then we already went through this Azure artifacts and Azure test plans. The Azure App Service runs on within a what? Within an Azure App Service plan. Azure App Service has some security benefits, including the ability to protect against switch vulnerability. Subdomain takeovers. Alright, securing Azure pipelines. Part of the job would be implementing security controls around the application and deploying code written by the dev team. Let's take the Think Factory web app deployment pipeline YAML as an example. As described in this previous task, this YAML pipeline sets up various reusable variables for the steps. Section defines a series of tasks that deploy the application code as an Azure App Service. Taking a look at some ways we can secure this process. You've been assigned to the review with the deployment YAML, adding some security controls. If you are missing, do this. We'll add a task deployment. Okay. Now and then one of the tests more detail. Is it tied to the last one where we create an app service or no? Key parts to understand going forward are the tasks. Tells Azure is going to be Azure command line interface. Display name. This is the human readable name of the task. Showing the UI pipeline logs. Inputs, as you might assume, this is where inputs for the Azure command line interface. Tasks will be tasks under. Okay. Now to understand tasks more detail. Let's create some. Okay. Our differences. Okay. Here's tasks. Here's what it will look like. So we're creating something similar, but not really. Just some minor differences about it. It looks like we'll be creating a app service. All right, let's do it. Repos. Let's go back to repos here. Files. Deploy web app.yaml. Okay, add the above task under the set PHP version. So are we copying this? I assume that the PHP version. Okay, so we're supposed to set it under this. That should be like that. Okay, let's see if this code works or whatever. Let's click commit here. Click commit again. Plus some security controls around the Azure. Okay, making more secure. Note that we can merge into the main without creating a pull request requiring reviewers. So the pass complete developers are break the code and full abilities in the process. Okay, implemented. Give them an amount of reviewers. Let's look at how we do that now. Okay, so it looks like we did good, man. Just copy pasted that onto that, made our code more secure. Let's go to navigate of how branch policies can be implemented. Navigate to branches tab. So let's go navigate onto the branches tab. Click this right here. Click this right here. Branch policies. Okay, then let's click the toggle button of require a mind. Right, let's click this toggle button right here. Require a minimum number of reviewers. Here are multiple options we can alter. For example, the number of reviewers keep at 2. We want to allow requesters to prove their own changes. We can check the appropriate box. However, to keep our control stricter, let's keep this unchecked. Now we get back to the repo. Click OK. Let's check the change will be set. Okay. Azure command line interface supports Bash and whatever language. Supports PowerShell as well. I got this answer from right here. Azure as well supports PowerShell. Which flags use in the Azure command line command/script to enforce HTTPS on Azure App Service? This one right here, HTTPS only true. Okay, nice. Yeah, we were able to require a minimum amount of reviewers using a what? Using a branch policy. Nice. Conclusion. The world of Azure DevSecOps introduced us to the role of a DevSecOps engineer, FinTech, as well as DevSecOps in the world of Azure. Step by step, you've been down around your new office in the cloud. Continue to learn more advanced Azure DevSecOps topics. You can be familiar with the environment, all the servers that can integrate to enable Think Factory's workflow. In the process, we have covered the benefits of hosting a web application in a cloud house hosted environment, Azure DevOps and its landscape, Azure Repos service and some security considerations, Azure Pipelines, Azure YAML pipelines, and Azure App Services / App Services plans, and as well as methods of securing a web application running in an Azure web application, and that just these sentences somehow just don't make sense. Methods of securing a web application running in Azure web applications using and how to implement some basic branch policies. That's a really wordy sentence. Wow. But yeah, definitely learn about Azure DevSecOps, right? The goal is to shift left, which means to obviously continuously making sure that our software development lifecycle is continuously being secured on every stage from the beginning all the way to the end. Like always, if you guys did enjoy this video, let me know in the comments section down below, and I'll see you when I see my next video. Peace out.